How are you, my friends? This video is about lecture 39, the last lecture in the algebra course, rational functions, asymptotes, and graphs. Here are the objectives of this lecture. We will define the rational function, and we look at transformations, asymptotes, and the graphs. What is a rational function? A rational function has the form f of x equals to p of x divided by q of x, where p of x and q of x are polynomials. They can be of any degree. Now, if we look at example 1, just as a review, this is the simplest rational function. F of x is equal to 1 over x, part A. Part B will be f of x minus 2 over x. Let's find the domain and range, the vertical asymptotes, the horizontal asymptotes, etc., etc. So we look at the first one. We see that the graph is the basic graph we have seen, 1 over x, the simplest rational function. Domain will be all real numbers except 0. Range will be all real numbers except 0. X equals 0 is the y-axis. This one we call it vertical asymptotes. See, the graph here is going up. It will never touch the y-axis, but it will be very close. So we call it x equals 0, which is the y-axis itself, is the vertical asymptotes. Now, y equals 0 here is the horizontal asymptotes, which is the x-axis. The graph here will go down, but it will never cut the x-axis. Decreases from minus infinity to 0 and 0 to infinity. This function is odd because f of minus x is equal minus f of x. Now for the second one, part B, we have the original function 1 over x, and minus 1 over x is the reflection of the graph with respect to x-axis. And now there is a vertical stretching a equals 2. So the solid graph is minus 2 over x. And these are the information about this function. Now, when we have 1 over x, that's the basic rational function. We can have functions like ax plus b. This is a linear polynomial divided by cx plus d. We can make synthetic division to find all the shifting, stretching, reflection, starting with the basic or the original function 1 over x. Let's see an example 2 now. In example 2, we have a function 3x plus 5 divided by x plus 2. Let's find all the stretching, shifting, reflection compared with the basic function 1 over x. So I can do here little synthetic division. See, 3 and 5 are the coefficients. On the chair here, I put minus 2. I bring the 3 down. 3 times minus 2 is minus 6 when we add minus 1. So this is the quotient, remember? That's the quotient here, q of x. And this is the remainder here is minus 1. So I can take this function and write it as 3, which is the quotient here, plus the remainder minus 1 over x plus 2. So easily I can see here no stretching because this is only 1. There is a reflection in the x-axis. There is a shifting 2 units on the left and 3 units up. So I will draw this starting with 1 over x. See, that's the basic. This is number 1. I'll do it by steps. Number 2, I say minus 1 over x. So this is the reflection in the x-axis. So instead of quadrants 1 and 3, it becomes quadrant 2 and 4. Number 3, we take the shifting 2 units to the left. See the graph here from this to this, it will go to the left. See, we see the red line here? That's the vertical asymptotes. And now we take from 3 to 4, this is the final graph. So it will be shifted up 3 units. So this one is the final graph. So the domain all real numbers except the vertical asymptotes, and the range all real numbers except the horizontal asymptotes. Here we will look at determining the asymptotes from the equation. if I need the vertical asymptotes, I have two examples down here you can look and see. Put the denominator is equal to 0 and solve for x. So this one is a function 2x plus 1 over x minus 3. What is the vertical asymptotes? Take the denominator equals 0, so x will be 3. This one we have 7 minus 10x divided by x squared minus 4. What is the vertical asymptotes? Two vertical asymptotes actually. X squared minus 4, this is the denominator. Put it equal to 0. It will be x equals 2 or x equals minus 2. Now to find the horizontal asymptote, see this is the horizontal. We take y equals, it should be y equals because it's horizontal, the leading coefficient of the function p of x divided by the leading coefficient of q of x, always like that. So if you have a function like 2x squared plus 7x divided by x squared minus 4, the leading coefficient here is 2, the leading with the highest power, and the leading coefficient is 1, so y will be 2 over 1. See, 2 over 1 is the horizontal asymptotes. Now, sometimes we have the numerator has lesser degree, like this one, 3 minus 10x, see power 1 here and here power 2. So the degree in the numerator is less than the degree in the denominator. So y will be 0, because if we put here x squared, it will be 0x squared. So take the leading coefficient, so it will be 0 divided by 1, which is y equals 0, which is the x-axis. The third type of asymptotes is the oblique. Oblique is a line, not horizontal, not vertical. When do we have oblique? We call it oblique asymptote or slant asymptote. We have that if we have the degree in the numerator is higher than the degree in the denominator. So what we do, we just use synthetic division or long division, use only the quotient. We will see now some examples. Now here example, find all asymptotes of the rational functions. So we have 6x squared minus 7x plus 12 divided by x squared minus 9. First one, we take the denominator equal to 0, so we can see directly the denominator equal to 0. We can factor it, x plus 3, x minus 3. So we have two vertical asymptotes. Now, we notice that the degree in the numerator is the same as the degree in the denominator. So horizontal asymptote will be y equals 6 over 1, which is 6. No oblique. Now note here the domain of the function f is all real numbers except the vertical asymptotes 3 and minus 3. Now the second one, we have x plus 1 over 2x squared plus 5x minus 3. We see here the degree is less. So if we put here x squared, it will be 0x squared plus x plus 1. So what will happen here? To find the vertical asymptotes, we factor the denominator, so 2x minus 1x plus 3. So we have two vertical asymptotes. Now in the horizontal, we have the degree less, so y will be 0 is the horizontal asymptote, which is the x-axis. No oblique asymptotes. Now the third one here, x squared plus 1 divided by x minus 2. There is no horizontal because the degree in the numerator is higher than the degree of the denominator. Now the first one is easy vertical asymptotes, x equals 2, finished. Now to find the oblique, I use synthetic division here. The coefficient here 1, 0, you know there is missing x up, 1. And then I put here on the chair 2, 1 comes down, 1 times 2, 2. Only use quotient. So y will be x plus 2. This is the oblique asymptote or slant asymptote. Only take the quotient. Now to graph rational functions, there are steps that we know. 1, 2, 3, 4 is important. I will explain now. And then 5 and 6. You know, first find x-intercept, let y equal 0. Find y-intercept, let x equal 0. Find all asymptotes, vertical, horizontal, and slant or oblique if there is any. Then plot some points as necessary. We sketch the graph. Now, number 4 is important. Sometimes we determine whether the graph will intersect the non-vertical asymptote, either horizontal or slant. Let's concentrate on the horizontal. So sometimes the graph like this will cut the horizontal. So what do? We take the function and we take the horizontal. Both are y. See the horizontal asymptote y equals b. And then we take the function itself where y equals that. We put it equal to each other, then we try to find x. I will show you more than one example. Now let's graph here the rational functions. 4x minus 4 divided by x plus 2. I think this one is so easy. This one is important. We will see why. So the first one, let's find x-intercept. Put y equals 0 here. See y equals 0. Cross multiply, so x will be 1. Easy. Y-intercept, let x equal 0. 0 and 0, y will be minus 2. So we have 2 points there. The vertical asymptotes, let the denominator is equal to 0. X will be minus 2. It's there. The horizontal, same degree, y will be 4. The leading coefficient over the leading coefficient. No oblique asymptotes. This is number 4 here, guys. Check if the graph intersects the horizontal. See the horizontal, I found 4. See? So I put 4 equals the function itself, always. So I put f of x is equal y equals 4. 4 is coming from the horizontal. If I cross multiply, 4x will be canceled. So minus 4 is equal to 8. Not logical, not correct. Minus 4 is equal to 8, not correct. So no intersection. So the graph will not intersect the horizontal. Here we can find some points. If I take x equals minus 5, replace it in the function here, I get 8. Let's see the graph now. See, I put x-intercept. You see this x-intercept? I put y-intercept. I put the vertical asymptote. I put the horizontal. And then I take 1 point here. See, I took minus 5. I'll show it to you. See, minus 5 here. Just pick any number you like. It will be 8. So minus 5 and 8 is the point. And we have checked that the graph, this graph, you will never cut this horizontal. So the graph will become below because we have this point, this point. So the graph will be on this side. It will be on that side. If you are suspicious about any number, let's say minus 4, minus 3, 7, 5, 6, just replace it in the function and you will see, like if you replace 5 there, so you replace 5, it will be somewhere here below 4. Now the domain from minus infinity until minus 2, union minus 2 to infinity, which is all real numbers except minus 2. You can write it this way or this way. Both are acceptable. The range, all real numbers except the horizontal asymptote. So minus infinity to 4, union 4 to infinity, or all real numbers except 4. Let's see the second one, please. 2x squared plus 5x minus 16 divided by x squared minus 16. Now the second one, let's factor up and down. That's why it's important. Little tricky. So let's factor 2x squared, 5x minus 12. We factor it like this, x squared minus 16. We factor it like, we can cancel x plus 4. Now remember, we have a new function here, 2x minus 3 over x minus 4, but we have to write a condition for x cannot be minus 4. So this will be always there. It has a missing point. The function, the graph, has a missing point at minus 4. Now, x-intercept, let y equal 0 in the new function. Y-intercept, let x equal 0 in the new function. So the vertical in the new function. This is the denominator here, so x will be 4. For finding the horizontal in the new function, y is equal leading over leading coefficient, so y will be 2. Now we need to check if the graph intersects the horizontal asymptote, y equals 2. So what do? As we mentioned before in step number 4, 2x minus 3 over x minus 4, that's the function after simplification, is equal to 2. Cross multiply, you get 2x minus 8 is equal to this one. So minus 3 is equal to minus 8, no intersection, because this equation is not correct. Now to find y of the missing point, see we have a missing point here at x minus 4. I replace minus 4 in the function after we simplify it. We get 11 over 8. So the missing point, or we call it whole, is minus 4 in the x, 11 over 8 in the y. Some points, let's take x equals 5. We can see now on the next slide to see the graph. If I take 5, it will be 7. You see, this is 5 and 7. So there is x-intercept and there is y-intercept, these points. And then there is a hole here. See the hole? Minus 4, 11 over 8, less than 2. And we have the horizontal, we have the vertical, x equals 4, and we have the point 5 and 7. So this is the graph. Now let's see the domain. All real numbers, remember, all real numbers except the vertical asymptotes and the x from the hole or the missing point. So except 4 and minus 4. Now, if you look at the range, these are the y values. All the real numbers except the y values. The y values are the horizontal asymptote and the y, see the y from the missing point or the hole. Because domain is related to x and the range is related to y. Now, if the point xy is a hole in the graph of the rational function, find the value of 4xy. See, this question says that we have a hole in this function in the graph, and this point is xy. Let's find 4xy. Now, if you go to the previous example, 4, this is the same question. Cancel x plus 4. See the same question? 2x minus 3 over x minus 4. I found x at x equal minus 4, where we have a missing point or a hole. We find y 11 over 8. Just in this question, we multiply 4xy. 4 times minus 4 times 11 over 8 is minus 22. Nice question. Example 6 is important. If the graph of the rational function intersects its horizontal asymptote at the point AB, find the value of a plus b. So the question says that the graph intersects the horizontal. So first we find the horizontal asymptote. See, the horizontal asymptote is the leading coefficient over the leading coefficient. See, 3 over 2. So y will be 3 over 2. All right. No need for factoring, but why we factor? To make sure there is no cancellation. You can factor it, but there is no need. Just to know the vertical asymptotes, but not in the solution here. So 3 over 2 is the horizontal asymptote equals the function itself, you see? Cross multiply now. See, 3 times 2, 6x squared plus 36 is 6x squared plus 15x minus 9. Cancel 6x squared. So 15x is equal to 45. X will be 3. So at 3, we see the graph here. See, I put the graph only to show you the graph will intersect the horizontal at 3. Then it will come back close to the horizontal. So 3, I put it in the function there. 3, I put it in the function. I get 3 over 2, or it's already 3 over 2 in the y. So a plus b will be 9 over 2. Now here we have the graph is given. See the vertical asymptote and the horizontal asymptote and the graph. And the function ax plus b over cx plus d. Let's find this function. This might be in an exam, like a multiple choice. So it will look like this. So the given function a, given b, given c, given d, given e. So the idea here is to go to the graph. From the graph, you draw the information about vertical, horizontal, the x-intercept, and then you can find the function. So you build the function. So from the graph here, we see the vertical, x equals 4, right, from the graph. So the denominator will be x minus 4. So we have x minus 4 in the denominator. Now horizontal, see the horizontal y equals 3. So this will be a over 1, leading over leading coefficient. So a will be 3. Now I can see the x-intercept here, 2, 0. See the x-intercept, 2, 0. So I can put in the function 0 for the y there and 2 for the x up and down, 2, and there is a 2 here. And then you can find b will be minus 6. Now, so the function, we can write it as 3x, see that one, 3x minus 6, which is plus b over x minus 4. Now, if you look here in the choices, you don't find the exact one. But if you multiply up and down by minus, you get 6 minus 3x over x, 4 minus x. This will be the answer. D is there. Yes, correct. Now, let's find the domain and the range of the rational function. This is a big rational function. So when you see a rational function, it's easier, good advice, that you can factor up and down to check if there is any cancellation. That means missing point or whole. So we try to factor in the numerator here. It will be 2x minus 1x plus 3. Just check it, 6, yes. This is x minus 2x plus 3. So I can cancel x minus 2, see? And then I write x cannot be 2. I can cancel x plus 3. Then I will write x cannot be minus 3. Now the new function is 2x minus 1, which is straight line. See, the function has 2 missing points or 2 holes. Let's take x equal 2 in the new function and find the y. It will be 3. So the hole is at 2, 3. Let's take minus 3 for the x. Put it in the function. See, 2 times minus 3 minus 1 becomes minus 7. So the hole is at minus 3 minus 7. Use the new function. In this case, since we have a straight line here, linear function, no vertical asymptotes, no horizontal asymptotes, no oblique asymptotes. Just a straight line. I can take the 2 holes if I like, because there are points on the line, but there are holes, so they are open. So this is 2, 3. See, the x is 2, y 3, and this is x minus 3 minus 7. I can take any other point on this line, 2x minus 1. Now let's find the domain. All the real numbers except the x values. See, the x values are 2, and the x values is minus 3. In the range, all the y values, all real numbers except the y values, the 3 from the y and minus 7. Now I will leave here some questions for you to practice all the exams questions. This is question number 1. We have a function t, tell me the stretching, shifting, reflection. Question 2, find all asymptotes of these 2 functions, each one separate. Graph this rational function and find the domain and the range. If the rational function has horizontal asymptote minus 2, find 10mn. There is m and there is n. Okay, find these values. Where the graph of this rational function is above the x-axis, so you have to check and see where is the graph. You have to graph it for sure. And then if the graph of this function y equal x squared plus 1 over ax squared plus bx plus c has horizontal asymptote y equals 1, 2 vertical asymptotes x equals minus 3, x equals 1, then find the product a times b times c is equal to multiple choice. So choose the correct answer after finding a, b, and c, then multiply them. In this one, we have the graph given, and the function, it should be in this form, f of x, ax plus c divided by 1 minus bx. So you have to be careful. Look at the graph, find the function, put it in this form, then find ABC. Now, question number 8 is a good question. We have to find the equation of the rational function given some information without the graph. So it says here, the equation of a rational function, vertical asymptote x equals 4, horizontal asymptote y equals minus 1, x-intercept 3, 0, and the whole at x equals 0. So you have to build the function, then choose A, B, C, and D. Now, as usual, this is the answers only for the 8 questions. And please, if you want to see the complete solution, of all these questions, you can go to all the exams questions, rational functions, lecture 39. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is lecture 39, the last lecture in the algebra course. Thank you for listening. I wish I can see you in another video with another topic. Thank you very much.